learning target, blah, blah, blah. Listen, we're learning how to factor, and we're going to learn why we have to learn how to do this. Okay. Quick little review here, and this is kind of what we've talked about before. Do we remember what a zero of a function is? Cole, what's a zero of a function?
A function's value is 0.
Where the function's value is 0. I like that. So let's see. It's the value of x that makes f of x equal to 0. Is that the same thing that Cole just said?
Yeah.
The function, f of x, when it's 0.
Yeah.
So think about that. Where are the zeros? Everything that touches the x-axis. These are zeros. Is this thing over here that I'm pointing to?
No.
Is that a 0 where it touches the y-axis? No. And why is that? Because think of the coordinates. I have a picture here, a better picture. Here's a better picture. Think of the coordinates of these points. Now, it's a little hard to read their x values, isn't it? But what's their y value?
0.
Right, we'll try. It's hard to read their x values, but their y values are 0. That's what we mean by when is the function. When is f of x? When is y? F of x and y, they mean the same thing, right? When is y 0? Always on the x-axis. And x-intercept is 0 in the function. So we have to kind of know this. And for some reason, some people struggle with this. And I'm not sure why. It's very simple. Where does the function cross or touch the x-axis? That's what we call the 0. What? That's okay. This is 0. If you had a function that went right through the middle. Oh, that's okay. So it's negative 2.3, right? So the x can be anything, right? But it's the y that's important. It's 0. It's 0. Okay, so we have to keep that in mind because we're going to be using other words. And it gets confusing. We're going to be talking about finding zeros of a function. We're going to be talking about finding solutions and roots to an equation. Some people use these things interchangeably. And there's subtle differences between them. So let's kind of talk about them. A 0 of a function is where that function equals 0. It's the xy pair that is the x-intercept of a function, right, that we just looked at. When we talk about solutions, we're talking about solutions to an equation. 4x equals 8. What's the solution to x equals 2? It is the value that if you plug it in here, you will get a true statement. That's what a solution is. Now, a root. Let's think of one that looks like this. X squared equals 4. What's the solution? What else? There's another solution.
2 times 2.
Negative 2. Look at this guy. Because what's negative 2 times negative? Remember, solutions are you plug it in and you get that. So 2 times 2, got it. Negative 2 times negative 2. That's the same. So these are solutions. We also call these roots. Think about why we call them roots. How do you get there? How do you know it's 2?
Simple math.
Well, what simple math did you do? You took what? You took what am I doing here?
Square root.
You took the root. You took the square root. I could have done this. X cubed equals 8. What's the root? 2. So we use root almost interchangeably with solution. Okay? You're going to hear all these words. This is what they mean. This is what they mean. Zeros of a function where a function's value is 0. That's almost like a picture. Here it is. Here's a 0. Here's a 0. An x-intercept, that's another name for a 0 as well. It's where that function crosses or touches the x-axis. Roots and solutions are kind of the same thing. Solutions mean you plug it in and you get a true statement. So that's working for all of these. But a root is kind of how we find the solution in a way. These are almost interchangeable, and these are almost interchangeable. You will see people that will say this and they mean this, or they'll say this and they mean that. Not the end of the world, but you guys know the difference now. You guys know the difference. Okay, so let's see. A first degree polynomial. What's degree mean? Degree, what's degree?
The highest,
Highest exponent, I like the way you said that. So if you have y equals mx plus b, our friend y equals mx plus b, remember this thing? This is, what degree? What's the degree? 2. 2, why do you think 2? Okay, you know what? I'm thinking is not bad thinking. Remember what these are. These are like model equations, and they're a placeholder for a number. So I absolutely see why you said that. You're not wrong. But is this of the form y equals mx plus b?
Yeah.
So when I'm looking at a model like this, we don't think of m and b as variables in the sense that we usually think of variables. Let's think of them more as placeholders for constant. So if I ask the same question here, what's the degree of this equation? 1. Because this one, right, there's one variable, degree 1. So this is really degree 1 as well. First degree polynomials will graph to what? What? Right, what?
This x and x on 1 and sigma plus
X over 1?
Like it goes 3x over 1.
If you do this
No,
like
3x.
To the 1 power? It's not that it's wrong, it's not in simplest form, and I always wanted it in simplest form. But yeah, you're thinking of there's the 1 there, and that's how I'm remembering it's degree 1, and that's true. So if that helps you remember, it's no problem, you're working on a problem, you can put it in there. But if you're giving me an answer, I don't want to see it because I always want simplest form. But yeah, you can put it there if you're trying to figure out degree. These are lines. Lines are what we call first degree polynomials. I mean, does that make sense now? So how many zeros will a first degree polynomial have?
1.
It's not, I'm underlining.
Oh.
Sorry. Yeah, let me get rid of that. That's confusing. It is degree 1. It's not over it. It's just like what it is. It's a first degree equation. It does have 1 0. Can we write a first degree polynomial that has 0 zeros? Don't have any?
No.
Yes. And then you said yes.
Oh, I did?
You did. What might it look like?
On the
It can't cross the x-axis, so what might it look like? What do you think, Brian? Oh, I love everything. Y equals 3, right? He said y equals, I am like so excited about that. Because if this is y equals 3, he remembered that the y equal is the horizontal one, right? And virtual gold star for you, my friend. That was a beautiful answer. Will this ever cross the x-axis? No. Yeah. Can I think of a way for a line to have 2 zeros? Straight line, right?
Actually.
So the thing when I say it has 1 0, it can have as many as 1 0. Sometimes it doesn't have any. Okay, so it can have as many as 1 0, but it could have less. Alright, so that's when you have a first degree. Well now, what about second degree polynomials? Oh boy, these are called quadratics. We are going to be spending tons of time with quadratics kind of in the next unit, but I want us to kind of start talking about them here. A quadratic is a second degree polynomial. Look at this guy. What's the degree of that polynomial? 2. Remember how that works? This monomial has degree 2. This monomial has degree 1. This monomial has degree 0. 2 wins, right? Always write them by convention in this order. Biggest exponent first. By convention, we always write them that way. Get in that habit. This is a degree 2. It's a quadratic. That's what we call them. Now, how many zeros does it have? Let's take our little calculator, and I hope you all brought calculators with you. So, if not, okay, so remember what you did. You turn it on, you press y equal, and I want to type in x squared minus 3x minus 10. The x, you may or may not remember this. If you can find your alpha button, don't press it, but look for it, and look one to the right, that's your x is. If you guys know where square is, kind of go down that first column so you see x squared. minus 3, go back to the x, which is next to the alpha key, minus 10. You're going to type that into y1 equals. Everybody doing it? You want to make sure we're having this problem, right? This part here? Okay, press the graph button. How many zeros? 2. 1, 2. See how easy that is? So it's something like this. It has 2 zeros. So there's one over here, looks like it's -2. Down 1 over here at 5. And these are very typical shapes of the quadratics we're going to be looking at. So it's like a big smile. Now, can you think of a smile that does not have 2 zeros? Can I draw this kind of smile any other way? Well, I don't even need the equation. I just want to know, like, this one, it kind of goes like this. Can I draw it another way so that I don't have 2 zeros? Yeah. Ryan, yeah, what do you think?
You can draw it like quadrant 1 to quadrant 4. Like sideways.
Oh, sideways. Very good point. Except I want it to be a function. Now, if you draw it sideways, oh, that's really clever. Is this a function though? It's not a function. Remember how functions, right? We got 1x with 2 y's. I like the thought though, but now I just want function. So always keep it in that smile shape. Yeah. Yeah, I want it like this shape with not 2 zeros. What do you think?
The bottom is small and the upper below the x.
So I just, whoops. How many zeros does this thing have? 0. You kick it away. Whereas now 1 0. Think about it just kind of dipping down and it just touches it and comes back up. So think about this. So it can have 2 zeros. It can have 1 0. It can have no 0. So if you have a second degree polynomial, it can have as many as 2 zeros. But it could have less. It could have less. And so just for laughs, we're not even going to use the calculator. If I gave you a polynomial that looks like this, and I'm just making it up. Here's my polynomial. What's the degree? 3. So Gigi, how many zeros do you think? This time, what I did, it had degree 1 as many as 1. Degree 2 as many as 2. Degree 3 as many as 3. 3 or less. So this is why knowing degree is important. It helps us figure out the maximum number of zeros I might have. And this is all because we want to learn how to graph these. We know how to graph linears, we don't always know how to graph these. So finding zeros is an important anchor. So we want to be able to find zeros of these quadratic functions. That's why we're here. That's why we're spending time right now. How do you find zeros? Okay. When a polynomial function is set to 0, we solve it by finding the roots. Meaning, you're going to take x plus 3 and make it into an equation. And I want to make it into an equation. What will f of x be for zeros of a function? Yes, sir? But I want a number. So, like, think about it. So, zeros of a function. What's the y value? Which is the same with the f of x value. 0, right? So what should I set this to? 0. Now it's an equation and I can find its solution, or its roots, right? Another way of saying it. What is the solution to this? And that will be where the 0 of this is, -3. Remember what this looks like? It looks like this. But I found the 0 of that function. You take the function, you set it equal to 0, you solve for x. Yes? What?
It is negative.
It is negative, right?
Because
well, look at that. Remember what a 0 is? It's the x-intercept. And that will be at -3. Here it is. And that's what it looks like. I happen to know what the y-intercept is too, because I know something about linear functions. Okay. So finding the zeros of a higher degree function is a little harder. And so let me see if I have that example again. X squared minus 3x minus 10. Let's say I had x squared minus 3x minus 10, and you told me I set it to 0, right? That's how you find the zeros of a function. Do we agree with that? This is the key thing here. To find the zeros of a function, set it equal to 0. How do I solve this thing? Like, I know what to do here, right? I subtracted 3 from both sides. What do I do here? I want x by itself. Add 10, that's a good first start, right? And I want to isolate x.
Subtract
Well, add it.
add it.
Okay, we can do that. What do we get? We get x squared equals 3x plus 10. Am I getting close? You get an x by itself? Divide by x? Well, if I divide, remember everything gets divided, right? X equals 3 plus 10 over x. I get close to getting x by itself? No. Here's the problem. Once you get past the linear equation, remember all this stuff you've been spending years now learning how to solve a linear equation, right? Factors of equality, subtract. Doesn't work when you get past the first degree equation. I cannot use the ways that you've been taught how to solve equations once it starts being quadratic or higher. This does not work. Can't isolate x the way we know how. Ruh-roh. But factoring is the thing that's going to help us solve it. Is this? Yeah, it is. All right. Now, we're going to find zeros graphically. We started doing this before. So we're going to do it again. So with the graphing calculator, let's try this. Let's graph the function y equals this quantity x plus 1 times that quantity x minus 2. You're going to need to enter it exactly like it is with those parentheses. Press y equal. Press the parentheses here, x plus 1. X plus 1, close paren, open. And remember x is near the alpha key. X minus 2, close it. Right? Does that match exactly? Let's graph. Ooh. Two. What? Remember what we call these ones? Starts with Q.
Quadratic.
It's a quadratic. It is. What are the zeros, right? And so if you graph, it's very easy to find the zeros. You just look. Well, let's see. Can you see what it is? It looks like negative 1 and 2, doesn't it? Now let's compare that with what we started with. Now I wanted to find the zeros, right? So that means you set y equal to 0. And x plus 1. And I got negative 1 and 2. Any relationship between what we're seeing up there and this? Opposites. They're kind of opposites, right? This says plus 1, I took a minus. Now remember what a 0 is. It's the solution to that equation, which means if I were to plug it in, it should work, right? So if I plug in a negative 1 for the x's, what should I get? I should get that. What's negative 1 plus 1? 0. Do you even care what this is anymore? Does that equal 0? 0 times anything. Okay, so that's a solution. What happens if you plug 2 in? You get 2 plus 1 times, 2 minus 2. Does that work? Yeah. Okay? So when you're in this form, it's actually pretty easy to solve an equation when it's something times something equals 0. Okay? Now, algebraically, when I set f of x equals to 0, when I am in this form, simple. I basically want to know, well, gee, when is this bit 0? And then when does x plus 1 equal 0? Because if this bit is 0, I get 0 times something, I don't care what, well, I get 0. Don't I?
Yeah.
So when does x plus 1 equal 0? I know how to solve this equation. It's linear. Just subtract 1 from both sides. I can isolate x. And then, or, it could be that this side was 0. Because anything times 0 is 0. I'm going to set this equals to 0. I know how to solve that, right? Add 2 to both sides. Look, you get the same thing. We are using what's called the zero product property. And I believe this is on your paper here someplace. Yeah, it's in the middle of the box. The zero product property. All it says, and you've seen this before, if you have two things that you're multiplying and their product is 0, had to be that either this thing was 0 or the other thing was 0. That's how you get 0. That's what I'm using here. Look at this. Isn't this one thing being multiplied by another thing? So either this one was 0, so I figured out the number that made it 0, or this thing was 0. Zero product property. So far, we kind of follow it. Yeah. I don't think it's that hard. It's like to get to 0, if you're multiplying stuff, at least one of those things has to be 0. All right, so we're using this fact to our advantage to solve equations that are a little bit hard to solve otherwise. So solve this, you say when does x plus 1 equal 0? Or when does x minus 2 equal 0? Well, x is 0 at -1 or 2. These are two solutions. And we know there's two solutions because when I graph it, I can see where they are. They're right here, aren't they? And look, at -1 and at 2. So the graph shows me the same thing the algebra does. Thumbs up, middle down. I just want to see if we're kind of following, right?
How do you verify it?
How do I do what? Plug in? Plug in -1, just like you verify any equation. You just plug in this one, you have to do it twice, right? And then plug in with 2. That's how you verify any solution to an equation, all right?
Yeah.
Yeah, and it works. Yes, ma'am.
So, is it basically just the opposite?
Basically it is, but I want you to remember that you are solving for 0, because sometimes it's hard to see what it is. And we'll see some examples where it is. Okay, so for example, these are towards the bottom of your notes here. We're going to do some of these examples. I want you to solve these equations. Oh, let's see. You see where I am? I'm going to find you towards the bottom, right before it says the word factoring. Okay? So I want to solve this equation. Something times something equals 0. Well, it must have been that x minus 3 was the 0, or maybe it was the x plus 6 that was 0. So what's x? 3. Or x could have been -6. There are two solutions. Another way to see it would be to graph it. So I can just graph that exact thing. X minus 3, x plus 6, graph it. This is at 1, 2, 3. And now what can we root? -6. The picture tells me that as well. See if you can find the solutions to these other ones. See if we can find the other solutions to the other equations. Now you guys are looking for a pattern, right? So let's just take the LC. You can, but what happens when you get to C? Okay? So yes, it's the opposite because if you put a 7 in here, that gives you 0. If you put a 9 in here, that gives you 0. This may be a little harder to see, so just set 5n plus 10 equals 0. I know how to solve this, right? Subtract 10 and divide by 5, -2. Because look, if you plug in a -2, 5 times -2 is -10, plus 10 is 0. Right? And then same thing with this one, 4n plus 12. When does that equal 0? And so subtract the 12, divide by 4. So for these, it might be easy to see just straight ahead. These takes a little practice to see it. So you can work out and solve equations you can. These are the solutions. There are two solutions to those equations. Yes, sir.
I do the division first instead of any other stuff. I just call that. You said 5n plus 3 equals 0.
If you're doing the division first, just remember, everything gets divided. Everything gets divided. If you're doing it, that's correct now. But sometimes it's hard to do that first if they don't divide first. Alrighty. Okay, so this form here is a factored form of a polynomial. This is a factored form. It's something times something. When you multiply this out, what do you get? Well, FOIL, right? X times x, x times 6, minus 3 times x, and then minus 3 times 6. I'm going to combine with 40. So that's x squared plus 3x minus 18. This and this is equivalent, right? So if I have this equation, what's the solutions to this? 3. Yes. It is. Because aren't these the same thing? It's hard. I don't know how to solve it when it looks like this, but I know how to solve it when it looks like this. Our goal here is how do you reverse FOIL? How do you reverse factors? These are what we call prime factors because I can't factor them any more than they already are. And so we're learning how to get into this form because we can solve equations. That's why we're here. We're going backwards. We're going backwards. We're going backwards. So there is lots and lots of different ways to go backwards. So that's what we're learning how to do. We're going to learn 5 different patterns that you need to recognize to do these different backwards factoring, right? There are more patterns than that. We're just doing 5 of them. And so we're going to start today with type 1 factoring. Now we did this during a warm-up. What are factors? What are they? What's the factor? You don't have to this during the warm-up. What's the factor? What's the factor?
Something that numbers multiply by.
We're multiplying, right? And when I talk about prime factors, right? Prime factors are when we rewrite a number or expression as a product of primes. What are the prime factors of 6? 3. Right? 2 prime numbers multiplied. Do they give you 6? Okay. That's what we did during our warm-up. That's prime factorization with numbers. So we're going to be talking about factoring a polynomial. So I want to split up a big polynomial into smaller polynomials that multiplied together give me the original one. Just like I multiply this together to get to my original, we're going to be multiplying. So you're going to rewrite a polynomial as a product of lower degree polynomials, and they will be prime polynomials, which means the polynomials that we're working with can't be factored further. All right. So these are factors of a polynomial. How do you find what polynomial they are factors of? Multiply them, right? These are factors of a number. What's that number? Multiply them. So I'm going to multiply. X times x is x squared. X times negative 2 is negative 2x. X times 1 is just an x. 1 times negative 2. Combine your OI. X squared minus x minus 2. This is the factored form of this. So now we're going to learn, you start with this, how do I get back here? Right? We know how to go in this direction, now we have to learn how to go back. Right? So it's going to be a process. It's going to take us a few classes to get there. Lots of different ways to work these. Alright, so type 1 factoring. That's the first kind of factoring we're going to learn, and I'm on the back now of your notes. Type 1 factoring. These types, by the way, are not in any textbook. These are categorizations. I'm actually stealing it from a TJ teacher. She did a very nice job of categorizing them. I love how she did it, so I use it here. Type 1 factoring. You factor out a monomial. What? Okay. You're going to look for the greatest common factor in terms. And then you're going to reverse distribute. And then you verify. And I'm just going to tell you now, do not skip this step. And we'll see when we actually do one why this is so important. Okay? So on your notes, it says find a common monomial. See that very first thing on page 2? It says reverse distribute. Right next to it say verify by multiplying. I want you to write this in there because it doesn't say it. And this is extremely important. See the first line on the top of page 2? Where it says find a common monomial and a polynomial with GCF and factor it out. Perform reverse distribution. Everybody see that? Right next to it, write verify by multiplying backwards. Right at the top. Write that down, write that down. Because don't skip it. Maybe put a box around it. Where is it? You're writing it down. Oh, yes. Down to there. Okay. So examples of how this works. This is a polynomial, isn't it? Is this a polynomial? Yeah. What's its degree? 2. Okay, right? So how do you factor it? So watch what we do. We have to find the greatest common factor. Do that in 2 pieces. First look at the number. This is what we practiced during the warm-up. What's the greatest common factor between 6 and 12? 6. Right? The 6 goes into that, 6 goes into that. Now, when you look at the variables next, they're actually easier than the numbers. So x squared is really x times x, right? And x is just x. What do they have in common? X. Isn't that the same in both? No, this one doesn't have x squared. The only thing that's the same in both is an x. So the little secret here is, see how there's an x squared and an x? It's always the one with the smaller degree is your greatest common factor. Okay, so what do I do with that? What this is when I was distributing something, the thing that was outside the parenthesis was that 6x. Right? I'm reverse distributing here. So I got here by distributing something. What was I distributing? The greatest common factor goes out. Now remember I multiplied? What's the opposite of multiplying? Dividing. So if you want to find what that number is, you can divide these by that greatest common factor. What is 6x squared divided by 6x? Right? The 6 is, that's an x. What about 12x over 6x? right? The x's cancel out, 12 over 6. You just factored your very first polynomial. See now how it is a product? It's 6x, well, it's actually three things, three factors. 6 times x times that x plus 2. Think of that as a grouping of a factor. Three factors here, 6x and x plus 2. They are all common factors because I can't factor many more than they already are. Now verify says multiply back. I reverse distributed. Forwards distribute. 6x times x and 6x times 2. 12x. Did I get what I started with?
Yep.
And that's good. You're looking here as well. Did I get the greatest common factor? Are there any other common factors? No. But if you do find something like maybe you said 3 instead of 6, if you said 3, you would have gotten something else in here. But check and make sure this is reduced enough. Let's look at this example now. The greatest common factor, look at the 12 and look at the 42. So you got to think about the greatest common factor here.
6.
Is it 6?
Well,
Is it 12?
no.
Right? If you're having trouble, use that. You can factor this as 2 times 3, and then you figure out what that is. That's 2 and 24, right? So that's 21. 2 times 3 times 4, is that right? And then you say, what's in common? 6. Now I see, are there any x's over here? Are there any y's? So are there any variables in common? No. My greatest common factor is 6, which means to get there, I must have distributed 6. So now let's think about how we got there. So you can divide them by 6. Some people can just do this. 6 times what is 12x? I don't know what it means.
2x.
2x. If that is not easy for you to do, 6 times what is divide it. 6 times what gives me 42y. Or you can just divide that 6. Verify, multiply back. 6 times 2x is
12x plus 42y.
Does that match? Yes. This is that verify step I don't want you to skip. I don't skip it to this day, I do it. Now, I've done this I'm thinking about 113 years now. Getting close to that. I can do that kind of in my head, but I do it every time. I always verify I did it right. Let's look at this guy. Third example. 4x to the 4th plus 24x squared. All right, start with the numbers. We got 4, we got a 24. Greatest common factor. And raise your hand this time rather than shouting out. I kind of like to talk to somebody who's maybe having a little trouble seeing it. If you're having a little trouble seeing it, I'd like you to raise your hand because we have like our quick guys kind of shouting it out. You might want to volunteer for that, especially if you're having a little trouble. Ben, what is the greatest common factor of 4 and 24? 4. 4 divided into here, 4 divided into here. It's never going to be bigger than the smallest number, is it? Now, what about the x to the 4th and the x to the 3rd? Again, raise your hand, especially if you're having a little bit of trouble. What is the greatest common factor between x to the 4th and x to the 3rd power? Raise your hand. I don't want you shouting out. And if you don't see it, I especially want you to raise your hand. I want to help you talk through it. You see it or you don't see it? Look for somebody who doesn't see it. I'm looking for a great person to say, we all see it? I can call on anybody?
Yeah.
I can? Hey, what is it? Is it x? Is that, okay, I see a common factor of x. Is it greatest? Think about what's going on here. You've got x times x, right? 4 of them. This one has 3 factors of x. What is the same in both? There's x, but there's also x and x and x. And x and x and x. So it's always going to be the one with the smaller exponent is in both of them. Does that make sense? Please stop me right now if you're still not seeing it. This is like key. Once you see this, it becomes easy. But if you're not quite there yet, believe me, it's okay. Ask a question. Ask a question. It's really okay. We're all among friends. Yes.
So it's just the least amount of x's or variables.
Basically, what is the same? They all have 3 factors of x. So this happens to have 4 factors of x, but they all have at least 3 factors of x. That's the same. Just like this is 4 times 1 and that's 4 times 6. Oh, these 4's match. That's why I can take it out. All right? So you're doing that with x's. It's going to be the one with the smaller x on it. And please ask a question, because I don't want to kind of run by this and then you're forever at this point. Please ask if you have a question. Please ask if you have a question. Really, like, if you don't get it, I'm kind of begging you to kind of say I don't get it, because I want you to get it. This is essential. We'll never get to the next thing if you don't see this. So please ask.
I see it.
All right, what happens now? We're reverse distributing. So the 4x cubed was the thing that was outside. And I multiplied, right, and I got back up here. 4x cubed times what gives me 4x cubed up 4?
X.
All right, now we're doing this real fast. If you are not seeing this, please let me know. Because I don't want to say, oh, because 3 people have it, we're just going to fly by. If you don't see where this is coming from, please ask. Basically, what those people did in their head was they divided. The 4's became 1. 4x is on the top, 3x is on the bottom. Cross out 3 of them, you're left with an x. What about this? 4x cubed, and don't shout it out. Raise your hand if you know. 4x cubed times what got me to 24x to the 3rd power?
Roll 6.
Okay, tell me how you got 6.
Because 4 times 6 equals 24. And then you call it with x.
And basically, in your head, you know what you did? You divided by the 4x cubed. 24 over 4 is 6. The x cubes are 1, 6. Yes, sir, finish.
I was going to say if I did cross it out.
Okay, so you divided it, real. So now let's verify it. Multiply back. Do not skip this. First of all, it's going to help you get much better at your multiplication. And this one?
Yeah, why don't you have a variable for x?
For this one? Because when I multiply that, think of this division. 24x cubed divided by 4x cubed, right? That's this. So the x cubed become a big old 1, right? And I multiply that and it matches up with it. I look in here just to make sure there's nothing left that I forgot to factor out. Maybe said 2, and maybe a 2 in here. This doesn't factor. Who kind of follows this? I mean, that's awesome. Who has a question? Who has a question? Yes, ma'am. Okay. Finding the greatest common factor? Okay. Let's do another example. Let's say I had 10x to the 5th, this one's just for Gigi, and 2x to the 3rd. And I wanted to factor it. So what you do is you say 10 and 2. Greatest common factor. Has to go into both of them. If you say 5, it doesn't go into this one. The greatest common factor, 2, right? It's never going to be bigger than that number. So if you take a 2 out, and then you say, now look at these guys. Here's 5 factors of x and 3 factors of x. What's the same in both? Yeah, there's 3 factors of x in both of them. Now I'm going to reverse distribute. 2x cubed times what gives me that? And it helps if you just put this like this. What's 10 over 2? I'm sorry, what did you do? Right? X to the 5th over x to the 3rd. You got 5 factors up here, 3 factors there, you can cross out 3 of them. How many are left? 2 of them. So 2 factors of x. Then we do this over here as well. 2x cubed. Well, 2 over 2. Next, there's what? X cubed over x cubed is also 1. And then when you multiply this back, you should get this original thing. 2 times 5 is 10. X cubed times x squared. That's 5 factors of x. Plus 2x cubed. You get that there. So when you're working on this at home, just really take your time. Don't rush through it. Don't rush through it. This does require you're real good with factors and stuff. So if your numerical factoring is a little rough, it may take you a little while to get into it. All right. Let's finish the baby up here. Why do we factor again? Why are we going through this? What's the factor? Well, yes, besides being fun. Yeah. What is the mathematical reasons you're going through this? We talked about it a little bit in the beginning. Why?
It causes zeros to polynomials.
It does. It finds the zeros of polynomials because it's going to help us solve equations that aren't linear. So, words. Okay, let's do an example rather than reading the words here. So, starting with polynomial. Now, I'm kind of in the middle-ish of page 2 here. This one, it's all written out for you, so you can just kind of look up for this one. I have this equation, 2x squared plus 8x is 0. You know what I can't do? Remember the old way? Oh, why don't you subtract 8x and, you know, like, I can't do it. I'm not going to be able to isolate x because I've got an x squared here and an x. I can't do it. So here's what you do. It says put all terms on one side of the equation, 0 on the other. Okay, it already is. Factor the polynomial. Okay. So I've got a 2 and I've got an 8. Does it have anything in common? 2. Now let's look at the x squared and the x. X squared and x, common factor? X. Does that have an x in it? So does that. I'm going to reverse distribute. Why am I writing equal 0? I'm solving an equation now. I'm not just factoring, I'm solving an equation. Now I've got to figure out. So 2x times something not equal 2x squared. What was that something to you? Yeah, 2x times what got me to 2x squared? X. And if you don't see it, you can just divide it by 2x. All right, 2x times something got me to 8x. Then 4. How do you get it? And it said he could do this really fast. He thought. Now let's verify. 2x times x is 2x squared, and 2x times 4 is 8x. I'm good. All right, now I'm in this form where it's something times something equals 0. Well, it's actually 3 things. 2 times x plus 4 is 0. Now, does 2 ever equal 0? Does it? No. So 2 is not the reason this got to 0. It must only be the variables. So if x is over here, what did it have to be to get 0? 0. So one possibility is this x is 0. Let's plug it in. Plug it in here. What happens when you plug in a 0? That becomes a 0. That becomes a 0. Does the equation become true? Yeah. Okay. Now when does x plus 4 equal 0?
Subtract 4.
Yes, what do you get? Let's plug that in now. 2 times negative. I'm putting it back to the original equation. Right, remember, this is how you verify an equation? Plug it back in. Negative 4 times negative 4 is what? Positive 16. Because it's negative times 2, that's 32, right? Positive 8 times negative 4. What's 32 minus 32? It works. It works. So by factoring it, I can find the two solutions. Because remember, we can have as many as 2 real solutions. I can do that too. Let's try another one. Okay, my first step, it says put all terms on one side, 0 on the other. Is that, am I in that situation? No. So I'm going to subtract the 21y. That's what I mean by put all terms on one side and 0 on the other. I want it to look like that. Then I can use zero product property. Then it says factor. Okay, 9 and 21. Oh, is there a greatest common factor? 3. Right? Goes into both of them. How about y squared and y? Y. I think the variables are easier. Equals 0. Don't forget to carry that down. 3y times something is 9y squared. Goodness, I don't know what it is, but I'm going to put the 3y here. What's 9 over 3? And y squared divided by y. Okay, put the 3y here. That cancels out. Minus 7. Just verify. 3y times 3y is 9y squared. 3y minus 7 is minus 21y. Good. So now I've got something times something is 0. You can even group these together. When does 3y equal 0? When does this thing equal 0? Really? Divide both sides by 3. Pretty good. Right? 3y equals all the variables is 0. Well, yeah, it has to be. When does this factor equal 0? When y is 0? That is the zero product property. When does 3y minus 7 equal 0? Oh no, let's add 7 to both sides. And let's divide by 3. And keep it a fraction. Don't make it a decimal. These are the two solutions. You plug in zeros, it works. If you were to plug 7/3 in, and you can verify that on your calculator, it will match. Oh, let's try this guy. First step, put all terms on one side, 0 on the other. I'm going to subtract that 36 from both sides. So I get 12h squared minus 36h equals 0. Are we okay from here to here? Remember, moving a term from one side to the other is just a sign change. If 36h is positive here, it will be negative here. Then it says factor it. 12 and 36. So h squared and h equals 0. Don't forget to carry down the equals 0. Alright. Yeah, I'm having a little trouble here. I want to talk to you. A little trouble. I'm like, yay. Nobody? You having a little trouble? No, I'm suffering here.
I am too.
Alright, so Danny, 12h times what gives me 12h squared? And again, you can just divide by 12h. H. 12h times what will give me that negative 36h? Negative.
Or negative 3.
Because h is what that's what. 12h times h is 12h squared. 12h times negative 3. I always take it out. Okay. Now, what are the possible values of h? It could be that with this business here that was 0. So when is that going to be 0? When h is what?
When h is
30? I'm looking at this factor now. There's 3 factors really. No, I'm looking at this one. Look what I'm doing. When does 12h or even just h? When does h equal 0? When it equals 0. Right? Because if 12 times 0, this is 0, you get 0 times whatever this is 0. Then I want to know, what about this factor? When does h minus 3 equal 0? H equals 3, right? 2 solutions. When you see a 2 here, you can have as many as 2 solutions. Hey! And then listen, you can factor this as well. If you factor this one, and again, it has to be everything on one side, 0 on the other. Let's say I want to factor 12h squared minus 36h. I go here, wonderful, I clear it, I make them x's, right? 12x squared minus 36x, because I only have x's here, so I'm not doing x's. There's something wacky here, but it's crossing at 0, it's crossing at 3. Those are the 2 solutions. Who followed this at all? Anybody? Couple people. Question. Okay, when we get to this state, do you see what the factors are? Remember what factoring is. It's multiplying stuff. I'm multiplying at 12, then I'm multiplying at h, and then I'm multiplying by an h minus 3. I really have 3 factors. When I multiply that together, I get 0. The only way that happens is something has to be a 0 factor. 12 is not going to be the 0 factor. Yes, 12. H. When does h equal 0? When it's 0. When does h minus 3 equal 0? When it's 3. So you're basically just going to set these little things up. H equals 0. H minus 3 equals 0. Sometimes it's done. Sometimes you have to do some solving. Don't go by opposite. I really want you to think about what you're doing. You are setting those factors equal to 0 and solving. You're looking for a shortcut. Eventually you can get there, but you can't do it right away. Now, here's what usually happens at this point. I say, okay, you try, and I say, go ahead. What is the solution to this equation? And people start multiplying. Should you be multiplying? No! This is factor form. That's where I want to be. What's the solution to this one?
x equals minus 4.
X equals 5.
X 5.
How'd you get that?
Spin.
If something times something is 0, so either this was 0 or this was 0. When does x plus 4 equal 0? When x is negative 4. When does x minus 5 equal 0? When x is 5. Right? So these are already factored. You don't have to factor it. So you're going to find the solutions. Now this part here, it just says factor. What does that mean? If I said factor 6, what do I want to see? 2 times 3. I want to see what polynomial we multiply. This is where you look for the greatest common factor, blah, blah. Now this is solved. To solve, you factor to solve. It's combining these 2 steps. Alright, so give this a try. What was on this page? the summary. Okay, give this a try. I'm putting up the answers here, so you can check your work as you go. But give it a try and ask questions. Ask questions. Okay, we have a question over here. How to keep the A as 0 and 8. Now we have to factor it, right? So it's got a common factor of A. That's it. So then I opened up my parentheses. A squared over A is A. 8A over A, right? I checked it and I got that. So I know this is factored right. I'm using the zero product property. Remember what it is. Two things, when you multiply them, you get 0. It has to be that A was 0 or B was 0. So I do have two things. I have A, and A plus 8 equals 0. So it must be that this A was 0, or this A plus 8 was 0. When does A plus 8 equal 0?
Oh, my God.
When A is 8. So you said this equals to 0, and you said that equals to 0. Solve those. I know how to solve those equations, but those things are good. Okay, how about this one? Did you remember to subtract this over?
Yeah.
Right? Then I saw I had a common factor of 3p. I divided both those things to get p minus 1. So this is a whole thing just to get here. Now, what do I do now? This times this is 0. Well, the 3 really has nothing to do with it, because that's 3. It's not 0. But when does p equal 0? When equals 0? When does p minus 1 equal 0? Okay. Now, assuming we know how to factor here, when does that equal 0? Well, negative 14's got nothing to do with it, right? M equals 0. When does 2m plus 1 equal 0? Subtract the 1 and divide by 2. Okay, so there's 3 skills here. One is when you are in factored form, can you solve the equation? The next skill is can you factor? And then you put them together. I'm going to factor and then solve equations. Like you go here and then you do this. Who's got a question? Well, this is like really, really essential here. Danny, what's your question? Where we lost? So we did these steps, right? Here? Let's just do this one real slow. Negative 28m squared equals 14m. First step is put all the terms on one side, 0 on the other. So move something over. If it's positive here, it will be negative over here. Equals 0. Don't forget that. Now I'm solving an equation. I need to factor it. Look at these numbers. Oof.
14.
And take out the negative with it. So the negative 14 comes out. What about m squared and m? Okay, now we're going to be careful. Because negative 28m squared over negative 14m.
Positive m squared.
Positive.
14, 2m squared.
2m. M squared over m. Okay. Negative 14m over negative 14m plus 1. And when you multiply back, you get here, yes. Now I have to figure out when does this thing equal 0. Negative 14 will never be 0. M is one of the factors, so it would be 0. What's that? When is 2m plus 1 equal 0? Well, I just solve that down here when m is negative a half. So just like up here, you solve these for 0, you solve for 0, you solve it for 0. You solve it for 0. Each of these factors will solve for 0.